Okay, so section 2.4 is going to be over complex numbers. So let's first talk about like a little introduction to complex numbers. If I take this really simple little equation and try to solve it, I can subtract 1 from both sides and then square root and have the square root of -1. Well, we know we cannot take a square root of a negative number. Well, this brings up the question was like, well, how do I handle these? Because this is an obvious solution to this equation. Well, in mathematics, we handle this by just putting a little I in the case for square root of -1, and we call this the imaginary unit. And we use this for equations where the solution is an imaginary number or a square root of a negative number, which we know we cannot do. So, if we have something like, say, square root of -4, well, that's the same thing as the square root of 4 times -1, which is square root of 4 is 2, so we'd say 2i. Okay, another example, square root of 36, since it's negative, we know square root of 36 is 6, so we just say 6i. Another example, square root of -81, 9i. Square root of -10, I, square root of 10. We do not need to leave the negative in there. Even if it doesn't simplify, we bring the I out. Here's another example. Square root of -8. Well, we can bring out a 2 and an I, and we have 2i square roots of 2. Okay? So, let's look at some things that happen if we start raising these i's to a power. So if we raise anything to the 0 power, I to the 0 power is 1. Anything to the 0 power is 1. I to the first power, obviously just I. I to the second power. Well, that is the square root of -1 to the second power. Will they undo each other? Which is just -1. Back to the real numbers. I to the third power, this is going to be I squared times I. We said I squared is -1, so this is -I. I to the fourth, I squared times I squared is -1 times -1, so +1. I to the fifth, that's I to the fourth times I, which is just I. I to the sixth. Let's see, that'd be, if you look at the pattern, it goes 1i, -1, -i, 1i, and then obviously it's going to be -1 I to the seventh, -i. I to the eighth is 1. I to the ninth is I. I to the 10th is -1. I to the 11th, -i. And it just keeps going and going and going. Well, you see it repeats every fourth time. So we're never, ever going to have a time where we should have I with an exponent on it. Never. Okay? So, if it repeats every fourth time, we can just take the exponent. For example, we have I to the 29th power. We can simplify that. We need to take the exponent, divide it by 4, so that goes in 7 times, with a remainder of 1. So this is the same thing as taking just that I and raising it to the remainder, which is just I. Okay, another example, I to the 47th power. Take 47, divide it by 4, goes in 1, 4, 0, 7. That goes in 1 time, 4, 3. We have 11 with a remainder of 3. So this is the same thing as I to the third power. And then we just said that I to the third power is -I. We can do that for anything. Say I to the 10,000 or 1,048th power. Take 1,048, divide it by 4. This goes in 2 times, 8, 2, 4, 6, 24, 8, 2, with a remainder of 0. So this is the same thing as I to the 0 power or just 1. Okay? So that's what imaginary numbers are. Now let's talk about complex numbers. A complex number is a number of the form a plus bi, where a is the real part and b is the imaginary part. So it has an imaginary part and a real part. Okay, for example, 3 plus 4i, that's a complex number. 5 minus 7i, complex number. Something that's purely imaginary, it's still a complex number. This confuses people because they think, oh, it's just imaginary. Well, that's fine, that's true, but it's also all imaginary numbers are complex numbers because they have 0 as a real part. Okay, now let's talk about doing some operations with complex numbers. These kind of work the same way as if you were dealing with a binomial, but it's not really a binomial, it's just a number. But we're going to treat I like it's a variable. So let's talk about adding and subtracting. We're just going to treat I like it's a variable and combine like terms. For example, say I have 3 plus 4i plus negative 7 or negative 5 minus 7i. If I combine just the real parts, 3 plus negative 5 is negative 2, and combine just the imaginary parts, 4 plus a negative 7 is negative 3i. Subtraction, same thing. 4 minus 2i minus 7 plus 9i. Add or subtract the real parts. 4 minus 7 is negative 3. Negative 2 minus 9 is negative 11. Okay. Multiplying. Okay, multiplying, we do what some people refer to as FOIL, or the distributive property. But this is not really a binomial, but we're going to treat it like it's a binomial. And we're going to simplify it in the end. And there's a difference here because whenever we multiply these together, we're going to end up with I squared. And we know that when we always have I squared, we have to simplify it. So that gives me 12. That gives me negative 9i. It gives me positive 8i. And that gives me negative 6i squared. Okay? You see the two middle parts combined. Negative 9 plus 8 is negative 1i. Then, over here, you see we have I squared, which is negative 1. So that is going to combine back in with the real number, and so we have 18 minus I. Similarly, 6 plus 2i squared, that's the same thing as 6 plus 2i times 6 plus 2i. It's going to be 36 plus 12i plus 12i plus 4i squared. Combine like terms, 36 plus 24i, and that is going to become minus 4, just because the I squared makes it negative, so it's just going to change the sign. So then we have 32 plus 24i. Okay, now dividing is going to be a little different. Before we talk about dividing, we first need to talk about something called the complex conjugate, because we're going to have to use it in the process of dividing with complex numbers. Complex conjugate says if a plus bi is a complex number, then its complex conjugate is a minus bi. Basically, just change the sign of the imaginary